Okay, so looking here at the Specialist Maths Exam 1 from VCAR 2021. So just explanation of the answers to questions on it. Okay, so these are my solutions and my explanation. So you should speak to your teacher and also look at the VCAR exam report, which I will refer to, but you should have a look yourself and get your teacher's interpretation. All right, so there'll be 9 videos, one for each of the question. All right, front of the paper. It's all general stuff that's on the front of pretty much all of them. And then we move on to the first question when we get there after a couple of blank pages. All right, here we go. Here, unless otherwise specified, an exact answer is required. All right, so that means fractions, surds, all of that sort of thing. In questions where more than 1 mark appropriate working must be shown, so if it's 2 marks and you don't show working, you will not get all marks. Things aren't drawn to scale, and in this case we're taking gravity as G and the value of 9.8. All right, let's get into question 1, 4 marks for all. It's 3 parts. First part here, the net force acting on the body of mass 10 kilos and the force is 5I plus 12J newtons. Find the acceleration of the body in meters per second squared. Okay, so Newton's second law, resultant forces is the mass times the acceleration. And so in this case, our resultant forces, there's only one as far as we're aware. So the resultant force is 5I plus 12J. And that equals 10, which is the mass, times A. And we're asked the acceleration. And so divide both sides by 10, and so half I plus 12 on 10, which is 6/5 J. All right, so the answer here is a vector, because our force here is a vector, so acceleration is. All right, so it says find the velocity of the body in meters per second anytime t, and we've got an initial velocity. So t equals 0, v equals -3j, and you'll notice there's vectors there again. So the answer will be a vector. All right, so we've got the acceleration. So to get the velocity, what we need to do is anti-differentiate that acceleration. So the half I plus 6/5 J, we need to anti-differentiate that with respect to time. And when we do that, we get a half Ti plus 6/5 Tj plus some constant. And so what we want to find out is what that constant is, and that's where our initial conditions come into it. So when t equals 0, v is -3j, so when I put that in, I get then that, so t equals 0, v equals -3j. Put that information in, -3j will be a half times 0, which of course is 0I, and then 6/5 times 0, which is 0j, plus some constant. So our constant then would be -3j. All right, so we're after the velocity at any time, and I haven't left us enough room there, so I'm going to come over here. So my velocity will be a half ti plus 6/5 tj minus 3j, which is the constant, which then, of course, you could say then that velocity is a half ti plus, and I can put the 6/5 t minus 3 in bracket, because that's the j component. All right, and so there is the answer to that. All right, 2 marks there, so we've got to show, must show working, so we've got to show this stuff here. All right, momentum of the body in kilogram meters per second when t equals 2. So momentum is mass times velocity, and momentum's a vector, so we're going to have a vector again. And again here, I haven't really quite left us enough room. So what are we talking about? Momentum when t is 2. So the momentum is the mass, which is 10, times the velocity, which is a half, and t is 2. So a half times 2i plus 6/5 times 2, take 3j is what we would get there. And so that is 10 times, half times 2 is 1. All right, this here then is 12/5 minus 3. Now in fifths, that's 15/5 j. So we get 10 times I plus, so 12 minus 15 is a minus. So let's change that. So 12 minus 15 is minus 3. Positive and a negative is -3/5 j, which then, of course, you can multiply that 10 in, and so you would get 10i and minus 10 times 3/5. 10 3s are 30. 30 divided by 5 is 6. So it's 6j. All right, and so there's the answer to the question. All right, so in this particular question, they're after the vectors, all right? So the momentum, the velocity, the acceleration, they're all vectors. They haven't used the word magnitude in there, so we need the vector. All right, so be careful that you answer and give what is required. In this case, it is a vector that is required.